What's up, everyone? I'm in a studio. I'm not in my house. Things have changed.
I love it.
I'm with a person. I'm not by myself. We promised you last week this would be a fun episode. And this is what it's going to be. A bit different. We're going to see how this works because I'm not used to presenting with someone in the physical, like next to me. So that's going to be interesting. And we've got a fun episode. You can see a little bit of a fun prop going on there. We will come to this in a bit, but let's kick us off. How are you doing?
I'm very well, thanks. Thanks for having me. It's awesome to be here.
Yeah. I mean, having two UK people as well is a benefit.
Easy.
Really nice to meet a show. But yeah, thank you for coming to the office and thank you for joining me here. But yeah, let's get into the show. So welcome everyone to the Keys to AWS Optimization, the show where we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Stephanie Gooch, and I'm a senior solution architect helping you with your cloud financial management. And today I have Mike, who is going to talk all about Spot and a very specific way of showing you the real life situation of Spot. As always, please feel free to put comments, questions in the chat. We want to hear from you. If you're a big Spot fan, let us know. And as always, if you have any general questions in the future and you want to get in contact, then please email costoptimization@amazon.com. But to get us started, let's hear your 1-minute origin story, Mike.
For sure. Hi, it's awesome to be here. So thanks, Steph, for having me. I look after what we call the flexible compute business in the UK and Ireland. So what does that mean? It basically means that we help customers use the cloud in a flexible way, be it more efficient, be it more optimal, like get the most out of cloud, essentially. I actually sit in a special part of the AWS organization called the Specialist Org.
Oh.
So special. Like what we did there. But I just wanted to call that out because we have a lot of AWS specialists in like many different AWS services. So be that compute with containers, serverless, flexible compute, networking, databases, analytics. And if you're a customer of AWS and you want to get more deep expertise in there, you always have specialists on the go too. Cool. Myself, I have a bit of a DevOps background. So I did a lot of DevOps delivery at a consultancy for a very long time. And yeah, now I'm a full and through AWS veteran now, I'd say 2.5 years. And as I said, with flexible compute, we look after a lot of the services that scale and shrink. So this involves EC2 Spot, which is the core bit of my business. We also have a look at auto-scaling groups. We have a look at Graviton. We have something called Carpenter as well. So it's all very exciting stuff.
Yeah, so many different things to cover. But as you said, we're going to focus on Spot today. So we know we've spoken about Spot on the show about 3 or 4 times in detail. So we don't want to go over old hat constantly. But do you want to give us like 2 sentences? What is Spot, so that we make sure everyone's on the same page? And what we'll also do is in the show notes below on YouTube, I will share a couple of episodes that you should watch so that you can get started if you are new to Spot.
Nice. So definitely go and check out that link because that's my US boss. So
give him some
he'll
support.
be happy. But good. Let's talk about Spot. So what is Spot? Spot is essentially spare capacity on AWS. So if you think of what the cloud is, the premise of the cloud, the whole point is that we want to grow and shrink our workloads when and if we need them. So with that in mind, we as AWS always need to have a lot of spare capacity.
Right.
So effectively, how we manage that spare capacity is we sell it off as a discounted rate, and you're able to utilize that, and that's what Spot instances are. You're able to make use of that discount. It's very, very good.
Okay.
There's a lot of misconceptions about Spot. So hopefully there's like a lot that you can kind of go and look into, but I'll just call out 3 kind of main ones. One is around bidding. We did have a bidding mechanism around Spot originally when it was launched, but it's no longer bidding at all. It's price that's set by AWS. It's based on long-term supply and demand. It makes it really simple. That's the reason that we changed that mechanism, just to make it really, really simple for that reason. It's really easy to adopt. So we have a lot of integrations for Spot, be that auto-scaling groups, be that some of the native services, be that partners. Carpenter's a tool that we helped open source, and it's a really, really cool way to utilize the Spot best practices. And one of the kind of beautiful things about Spot is that it helps you build in resilient practices as well. So by utilizing spare capacity, we as Amazon can take that spare capacity back if it's no longer spare. We'll only ever do that if we need it for on demand. But it's really, really good because you start building your architecture and the applications in a really resilient way. And it becomes a really handy way to not only think about cost optimization, but you also think about building resilience into your applications too.
Love it. I mean, the Carpenter shout out, I popped a link in, something really useful to get started with. And the bidding is a thing that people always like, oh, I haven't got time to deal with bidding. And we do this at FinHacks, which are like events that we do for cost. And every single time we talk about Spot, we always put a quiz question, which is true or false, you need to bid. And still, even though we're like, no bidding, people are like, yeah, you have to bid. It's like default. So no bidding, just a reminder. But yeah, the integration with lots of different tools, I think also people just focus on EC2, same as Graviton, where they just focus on EC2 and then think, oh, that's a little bit trickier than I have time for at the moment, when there is way more services to get started.
Absolutely. And just an additional point on that is just to think of like external products that you might use, like ISVs and other areas. So we work with a lot of different partners for lots of different tools. For example, if you are a Databricks user, that works on both Spot and Graviton too. So really always consider it's not just the native AWS services that support both of those kind of elements. There's other vendors and stuff that we work with to build those best practices in.
Perfect. All right. So we promised you something fun today. Do you want to tell everyone what this thing is that you have?
Of course.
And also the title might be like, what are we talking about? And where it came from as well, because I know there's a fun backstory to it.
Nice. So with any good backstory, this actually all started in a pub while we were having some drinks. And effectively, one of the things that we're talking about is very much like this conversational misconceptions that we were having. We were like, how do we prove to customers and to other viewers that actually you can build these best practices in and it doesn't take down an application? You don't have to worry about it being in production. And that's a really interesting thought when we're talking about Spot in production. We have customers that use Spot 100% in production. So I was lucky enough to do a talk with Guy Templeton from Skyscanner at the summit. I will also do a few repeats. It's not online, so hopefully it will be one day soon. But he talks about very much how Skyscanner did a very complex architecture. They were able to do that by using Spot, and they have 100% Spot in production. Wow. So by setting that scene, that kind of sets the scene nicely of why we wanted to bring some more elements to it. So we decided that it'd be really cool to create a retro arcade machine game that effectively is chaos engineering. And what we're gonna show here is we're gonna show, right, we're going to try and destroy the cluster. We're going to try and destroy the services running on the cluster. It's all running on Spot. By building these best practices around resilience and the application, you can actually keep your application running, you can keep the cluster running, and you can even keep the game running as well. So it's a pretty cool way to kind of play with it, and people want to get hands-on with this all the time. So it's a good way.
I think that as well, when I first saw it, when you showed it to me, the elements that it's like a tangible thing. So when you see it in a second, you'll understand what I mean, where it's like you can see the things going down, you can see the effect. And sometimes when you're dealing with Spot, especially if you're out there like, oh, I really want to do Spot, but because of X, Y, and Z, and because of leaders, and because people are worried about it, this is actually a great example that you play this video to them, cut into this bit and just be like, hey, look, this is a real example of Spot and how it would actually work in real life in a way that people can understand.
Love it.
Shall we get into the demo?
Yeah, why not? Let's go for it.
All right, let's pull this up.
Cool. So you should be able to see like a cool retro screen at the minute. And I paused it because I wanted at least 1 minute to explain what's happening and before we start destroying the clusters. But the key thing at the bottom of the screen that you can see is you can see a load of boxes. And those boxes are a real life graphical representation of a Kubernetes clusters that I am running at the minute. You see that you have different colors. So the cluster is running across different availability zones. And you can see on some of the boxes as well, they have red stars. And actually, I'm running the pure part of my data plane on Spot. So I'm running 100% of my data plane on Spot. I'm not necessarily running some of the critical Kubernetes services on Spot because they are not fault tolerant. We only want to pick fault tolerant applications that can work with Spot.
Okay.
Cool. Then each of those little boxes, you've got some very little boxes as well, tiny little boxes, and that's a replication of a service that's running across the cluster. Okay. So when we are playing this game, what we are essentially doing is when we shoot one of the aliens, we'll be running a kill command on the services individually, and we'll start seeing the services go down. if I'm lucky enough to hit a whale, and you know what, the amount of times I've been playing this and still how rubbish I am at it.
Oh my God. Well, you should let me try. I will be
maybe,
terrible.
like that. We'll get
games.
it. But hopefully we'll hit a whale. And what that will do is it will cause a spot interruption. So we have a service called Fault Injection Simulator, which is a chaos engineering service. And effectively what that does is it allows us to simulate spot interruptions, and it will actually cause a spot interruption.
Right.
So regardless of whether we're doing this chaos engineering, trying to destroy it, or whether a spot interruption happens naturally, we should be able to see that we can't destroy the cluster because it's too quick at interacting.
Yeah. And we'll go through at the end, like how this kind of integrates to what it looks like in real life again, to remind about this. But and before we start, I want to shout out Just Jess, who commented like I did when we started recording, before we started recording, which is, what is up with your laptop with no stickers? I was like, whoa.
I have a carpenter sticker on this side.
He's a purist. He only aligns to one thing.
To be honest, like as a Graviton Pro, I wanted to upgrade my laptop to be on an ARM-based chip, and that's why I didn't invest the stickers on the back yet, because I was worried that I was going to get a replacement laptop.
That is the worst.
I'm sorry, guys, I've let the team down.
No, it's fine. I'll give you a keys one after.
Yeah.
Okay, all right, let's go for it.
Let's do it. Okay, cool. So I'm just going to jump straight in and go for it, and we should be able to see. Oh, the joystick's gone down, but we'll carry on. Let's go again. We'll refresh it because it was a good start to the game. Woohoo! Still got the internet. Yeah, live demo. Demo gods, are you there?
Please.
Cool. Let's see if we go again now. Yeah, here we go. Right, I'm on my joystick.
Okay.
So I can see that the ship is moving at the bottom. I can see that my real life graphical representation of the cluster is at the bottom too. So I'm going to start shooting some aliens. Okay. And effectively, what we should be able to start seeing on the graphical representation of the cluster already is that we're starting to destroy services that are there. So the key to this game is I'm destroying as many of the services that I can. We can see that Kubernetes natively is coming back and trying to reschedule them in. Cool. So what I'm going to try and do now is when the whale comes in. Yes! Nailed it. Good. Good. Right. So we're going to give it a few seconds because the node is starting to kind of listen for spot interruptions, and you can start seeing that one is flashing. So you can see one of the green ones is flashing. So that means effectively that this is going to cause a spot interruption on my on that individual node, and it's going to have to say within 2 minutes we need to distribute the workload across to the other nodes as well.
And will that mean that the little boxes move to the other bigger boxes?
Exactly right. So in the meantime, I'm still trying to destroy the little boxes inside with the aliens. I've lost my extra weapons for some reason, but oh no. I'm not very good at the high score.
I know nothing about how to actually play this game, so I'm like, I've seen it in arcades.
Oh, that's showing my age now then. Good. Right. Okay. So we can try and destroy this as much as we can, but the really point is it gets quite boring once we've started playing it for 5 minutes because it just gets too ahead of us and it gets too quick.
Right.
So at least if we'll keep going for now, just to see until that node causes that interruption.
Yeah.
Just while we're waiting for that, just remember with spot interruptions, there are 2 types of notifications that you can get. One is like a warning. It basically says this node is at risk of interruption. Right. So you need to think about doing something with it. The second one is it's a termination notice. And the termination notice is saying, right, you've got 2 minutes to do something to this instance before we take it back. And you can actually see now that the instance that's flashing, it's now cordoned off all of the running replica services on there. So there's no more services running on that.
All the small boxes.
Yep, exactly. And it's gonna come back onto the other one. Oh, it's getting a bit trickier now. Here we go. Yeah. Oh, no. Come on. Oh,
that
see
was
how close
close.
that was.
So,
but
keep going.
we can keep going forever, like, to be honest. But key things are, right, is that even though I'm destroying the services, I'm causing more spot interruptions than are naturally happening, I am still able to keep the cluster running. And a fun fact is the game itself is actually running as one of these services. So it's a bit of an inception to get there with your brain, but if I was to cause an interruption on this service and it wasn't to work anymore, we wouldn't be able to play this game.
That is, so, like, I think the most, it's like quite meta.
Yeah, exactly.
That's the best thing about this is you're like, oh, well, that, like, theoretically all these boxes are dying, like, whatever, it's not real. And then you're like, no. One of these things is actually producing the thing you're playing on.
Exactly.
And so that takes it to a whole nother, like, what? When you told me that before, I was like, whoa.
Yeah, exactly.
That's like a nugget at the end. But, like, the fact that all these worker nodes are like, more nodes are coming up and supporting it I feel like I said, this is a very tangible explanation of it.
Yeah.
And remind me, so you got there's three different things to shoot in this, right? And can you just go through again what those the different ones kill again?
Yeah, for sure. So the aliens at the bottom, any of these ones, even though they've got different icons. Oh, I accidentally hit the whale then. That was good. What we can see here is that these are the individual services running. So the aliens at the bottom that are coming towards us are the services. So anyone that I try and kill here is destroying services on any of those nodes. That's a very Kubernetes native thing.
Right.
Okay. And when I destroy the whale at the top, it's causing a spot interruption to the entire node. So the bigger box surrounding the other services too. You can start seeing now that quite a lot of them are flashing, right? We've got loads of them flashing now. The game is still running on the ones that are still there. But if we kept going with it, if we called more people on it, I really reckon that we could probably take it down. Actually. Yeah. But we are really pushing it to the edge here, right? So this is the whole point in resilience. We want to keep this best practices going. We can use Spot. It's much like, as I said, you get up to about 90% discount. Like that's our typical marketing material says that. We typically say that customers can get up to about 68% savings as well.
More reasonable one.
But the key thing for me is that you're architecting in a completely different way. You're architecting for failure. That means the tolerance of your applications are going to last much longer, and you're getting this cost savings elements too. And as I said, you don't need to switch the whole thing onto production 100% tomorrow. But like, it's a good kind of way to like start thinking of that. Start putting it on in dev. Start thinking about that fault tolerance. Start thinking about those individual areas too.
Yeah, and I want to quickly give out a shout to Rob. This is arcade version of Chaos Monkey. Let me get some quarters. So he is dying to get a hang of this. So we were talking about it. So if people wanted to try this themselves, where are we with that?
Yeah, absolutely. So we are open sourcing this because we've had quite a few customers come up to us and say, I want to put Spot Invaders on my cluster and destroy my clusters at work. But you know what? We'd love to hear from people if they want to try this kind of element of chaos engineering. And the whole reason is that we brought it out that we brought this out to show and demonstrate that you can build resiliency into your clusters. You can make use of Spot 100%, and you still can't take down the application. So it's a really good thing to think about. And one thing that I haven't really delved too much into that I want to be really specific about is that Spot is only good for certain types of workloads. Okay, we don't want to be pushing Spot onto databases. It's not fault tolerant. They're not stateless. They're not flexible. The more that we can think about applications, and containers is a great example for that, the more flexible we can be with the instance types that are available means that we can leverage spare capacity from a bit of everywhere. And that's why we've got a really diverse set of types of instances, availability zones, and even at sometimes regions with customers where they're just utilizing the spare capacity from everywhere. I'm using my hands a lot because normally I have like these great slides, but just think that AWS has loads of instance types. If you think about all those different instance types there, you also have the spare capacity in each one of those boxes. So the more that you choose, the more spare capacity you can leverage.
And when you decide that you want to use Spot, you can set like a broad amount of different instance types to use, right?
Absolutely. So again, this is why I was talking about the integration. So for example, if you're using autoscaling groups, you don't have to be using containers, but autoscaling groups is another great example where we could say you're running a stateless application on there. It's just going to bring up another instance if the instance is interrupted.
And some examples of stateless, just in case people haven't.
Basically, a stateless is anything that doesn't store state on the instance itself, right? You're not storing anything on the host that you need. So think of it in that DevOps mentality, right? Can I destroy this server and recreate it without any data being lost? And that is a really good way to kind of think about that kind of stateless thing. We typically put it into several categories. So containers. Web services is a great one because you typically replicate a lot of web services across. We've got HPC because HPC workloads are typically running huge amounts on the cloud. So you want to do that in the most efficient and optimal way that you can. There's some DevOps elements as well. So you can put build servers on it, CI/CD. Effectively, if they get interrupted, they just carry on and just bring up another build server. We also see really interesting use cases with customers that are using Spot interruptions as a form of their tests. So they're saying, oh, it doesn't matter if Spot takes away this test environment. It's a good test of something coming down and bringing it back up again. So there's loads of different cases.
And I want to come on to Rob's question in a sec, but because I feel like I should have a go. And but the just kind of driving it home with this is people sometimes freak out about Spot because they might actually be not utilizing the cloud to its full capacity. So they might be using more of a pet versus cattle situation. And so that might be the real reason why people aren't using Spot. And I think that's kind of an uncomfortable situation to be in, to be like, oh, you're not actually using the cloud effectively, and that's why, because your stuff should be able to fail and you should be able to move. It should be on auto scaling groups. It should be able to expand and use things like containers and all this stuff. And that's the reason for doing it in the cloud, and that's one of the key benefits to it. I heard who was it that said this the other day? There was a quote. I went to the FinOps meetup, shout out FinOps Nation, in the UK, that was somebody said something like, if you're not using the cloud elasticity, you're just basically using another data center, something along those lines.
Exactly right.
It's that kind of thing. So Rob pointed out he joined. He didn't see the start, and so for those people, I feel like I don't want to rob any new viewers of it. So can I try the game?
Of course you can. Yeah, go for it. Let's go again. I just need to refresh.
As a summary, the game. I'm going to pull it back up. The game is demonstrating real life node. Why don't you do it? I feel like a real life. How do I do it?
It's all good. Just move left and right and shoot with either one.
Okay.
So we're pretty good to go, I think.
Guys, this is. Oh no, that's the thing.
Yeah, it's going. Look at it on here because of the
lag.
Otherwise,
guys, I don't have the. I wasn't a gamer. This is ironic. I have a Twitch show, and so as I'm shooting, as I shoot the small ones, I'm taking down the
individual
services.
Yeah, exactly.
And if I hit the whale, that's a full node.
Exactly right. So while you're actually playing it, I can actually show you, demonstrating. Look, I can see here, but if I highlight over them, it's telling me what that individual service is. That's just a simple Monte Carlo service running. If I highlight on the node itself, it's telling me the actual node. The red stars itself means that it's Spot. So there's 100% of the data plane on Kubernetes running on Spot. And if you're not familiar with Kubernetes, effectively, you have two elements. Control plane in Kubernetes means it's controlling where the pods and the nodes are going, what's going on where. The data plane is very much the application that's running. So we're running all of our application on Spot instances.
I want to try and get the thing. I have such bad gaming motor skills. That classic thing of, I didn't really play that many games as a child. My dad's watching is me so embarrassed. Anyway, I know we've only got just sort of but Rob said is that the game is actually running. Yes. So to confirm, this game is running on the nodes below. So that's right, yeah?
Exactly right. So this game is effectively a client that's talking to the AWS cloud behind. So it's actually all working in the cloud at the minute. It is working on a real-life EKS cluster. The service is running on an EKS cluster. And the game itself is actually running on one of these nodes as well. It will take me ages to find... was that it there? One of them's there. There we go. Look, there's the game. Spot Invaders. It's that little box on that one. So good luck into doing it. But it is running on the node itself.
All right. And we've got a question. So this is all on Spot instances. Yes.
The data plane is all on Spot instances. And again, if you're not familiar with Kubernetes, the data plane is where it actually runs the application. And the whole point is that we want to mimic where customers are doing it themselves. So if you've, unlucky.
I think the thing killed me. I didn't get whale the entire time. But there we go. Thank you for letting me play.
No worries. But great. If you ever have gone on to, for example, and use Skyscanner's website, they use 100% Spot on their production. So anything that you're using on a web service from Skyscanner is actually running on Spot behind the scenes. And they're able to do that because they're building these best practices in. Mm-hmm. Maybe they're not playing Space Invaders to destroy their clusters. I hope not in production, but the key element is still there. They built in resilience so that even if they got Spot interruptions, they could carry on.
So I want to touch on something you said earlier about Carpenter.
Yeah,
so do you want to, I don't think we've gone into detail a lot on the show about it before. So do you want to give a quick summary of what it is and what it does?
Yeah, for sure. It's got a lot of buzz. It's effectively an open source tool that AWS helped develop. And hopefully in the future, it's been announced that we're going to try and expand it to the CNCF as well. So really, really exciting. And effectively, it's a very Kubernetes specific tool. Okay, so it's very based around Kubernetes. Typically with Kubernetes, you have something called like cluster autoscaler, and that is basically growing the Kubernetes cluster when you're thinking about it from an infrastructure perspective.
Right.
Carpenter is a different scaling mechanism. It's looking more from the application first, and it's thinking from an application perspective. What do I need? How do I need to scale it? Instead of bringing up and thinking of infrastructure, how I'm going to scale it, I'm also going to try and put Carpenter in a retrofitted place. And that's actually a really great thing if you're thinking about optimization. So we've actually seen customers adopt Carpenter where they've seen like huge optimization benefits from the get-go, because it's just doing it much more efficiently in terms of the scaling. It's trying to fit services on similar sized nodes. And the best thing is it builds Spot in from default. So it's got the best practices of Spot built in. You don't need to think about that diversification because it's all built in for you. You obviously have the ability, you still have the ability to not go on Spot and to mix it with on demand and some other areas too. But it's a really great tool to look into. We run a load of Spot Carpenter workshops in the UK. We run them everywhere globally. So feel free to reach out to me. You can like add me on LinkedIn. I'll share some links. But definitely, if anyone's interested in learning more about Carpenter, we would love to help you on that journey.
Yeah, and we in the comments below and in the description below on YouTube, I'm having trouble saying description, so it's the second time I've fucked that up. But in the description, I'll put your LinkedIn so people can get there. And if you're watching on YouTube, don't forget to hit that subscribe button to stay up to date with all of our videos. So we've got 4 more minutes. So are there any, because I always like to think of people like they've watched this video, they've been inspired by the game, they want to go and do something now. Like what could they start as like a small first step maybe into trying to do a bit more Spot in their workload?
Great. So I tell you what, the first thing is really good. And I think you've posted the link there, ec2spotworkshops.com is a really good, it's a really good place to have a look and get familiar with Spot. Essentially, these are the tutorials that we run in our workshops, and it gives you a combination of running Spot in autoscaling groups, running Spot in EMR, running Spot on containers, whether it's ECS, EKS, or Carpenter, and it just gives you a step-by-step talk through on how you can adopt Spot and how you can make use of it too. So it's a really good place to start. Typically, when I go into customers, I will look into 3 things of whether they are kind of suitable for going on Spot in the first place.
Okay.
The first one is containers, because typically, by the nature of what a container is, it's immutable. You spin it up, you throw it away, you get a new one. Typically out of the box, that's fault tolerance best practice, and that's Spot best practice. There will be some use cases where people are storing state on containers for whatever reason. That's where it won't work. But typically, by looking at customers that are using containers, that's a really great way to optimize. The second one is EMR. You're running huge amounts of data workloads on compute. They absolutely can support Spot instances as well. And it's like a really, really good place to go. And the third one is autoscaling groups. And it's a bit of a mixed bag with autoscaling groups, because I think that further to that conversation you said, where people are still thinking about servers as pets in the cloud, a lot of people typically adopted autoscaling groups from the beginning, and there is still some very stateful things there. But if you're working in a stateless way with autoscaling groups, then the best practices are also built into that. You can even do it through the console. I can even say click Spot. I can even say I want to use 20% Spot, 80% on demand, and kind of mix and match them, and it will really help you on that journey. So really easy places to get started. Have a look at EC2 Spot workshops. You can run them on your own AWS account, or you can run them in a workshop. It's exactly the same material that we use when we run these workshops. So it's really, really simple and easy.
Perfect. And with autoscaling, what do you have a recommended percentage that should be done by Spot?
It's entirely up to your workload and what you want. I would always say start small, right? Start small on a lower environment in dev, test, whatever, and then up it as much as you can. But the beauty of it is, like, one of the things that we showed in the demo was fault injection simulator was the point that we can test what's going to happen when our Spot instances happen. So we can still do that on autoscaling groups. We can still go and test it and see how the application responds. If your application responds perfectly, there's no reason to even put a percentage limit on it. But it's a really good way to introduce and get things running. We also say that, okay, Spot is spare capacity. And if you are restricted in certain elements, such as instance type or region and things like that, then it's sometimes sensible to have a good percentage on the bottom to make sure that there is always something running on a non-immutable way.
And that you can cover by savings plans. So
exactly right.
Do that. Have that mixed approach. Awesome. All right. That is it from us today. Next week, we're going to be having cost observability using Amazon Managed Grafana, which is a mouthful of a title for next week, with John's doing that. For those, actually, there was a couple more comments in the chat, which we didn't get to do. So please feel free to email costoptimization@amazon.com or leave them in the comments on YouTube. And yeah, join us next week. We'll be chatting about that, and we'll see you there.